Yeah, welcome everybody from myself as well. So I'm Kirill. I lead the data analytics team together with Ole. Most of you I know already. The other ones I hope to get to know better during these next 2 days. So today I'm going to talk about a topic that I find quite fascinating. So let's get this straight out of the way. I like simple things, and I believe that usually the simplest approach is the right one. So I will try to convince you in that today, all of you. Why I feel qualified to talk about this. So our team at Project A, our job is to support the portfolio companies and make them data-driven and drive their business forward. So recently we started doing this outside of the portfolio as well. So we work with a bunch of different companies that have various different business models, and they're at various levels of data maturity. I would say during a year we built or are involved in building 10 to 12 data platforms, and over the years we've gathered a bunch of experience. What works well, what doesn't work well, what's simple, and what is complicated as well. So today I'm going to give you my thoughts on why is it so difficult to do the simple stuff well. Yeah, this is not greatly visible, but it's a list of all the tools that exist in the data space. So it's a landscape that is created by this VC in New York called the MAD landscape, quite appropriately I would say, because it's quite mad how many tools are out there. This VC invests in data tools, so every year they put out this list out there. It's probably also not a complete list. So one can argue that data people have never had it this easy. I mean, we have all the tools. But as you can probably guess, it's not the tools. So the tools can help, of course, if used appropriately, but most of the time it's not the tools. So today I'll do this talk by going over all data elements which a data team is usually responsible for, and then for each of them I will speak about what I believe could be simple and also what's complicated. So we'll talk about data ingestion, so getting the data from all the source systems into your data platform. Then we'll talk about the storage and query engine. Then we'll talk about orchestration, so how to coordinate all your pipelines executions and handle dependency. Then, and this is my favorite topic, we'll talk about data modeling. So this is the place where we establish the single source of truth. We define all our business logic and make sure that it's consistent. And after that, finally, I'll talk also about data activation. So this is a very broad topic, and it's a term that we started using recently, where we try to cover all the different aspects that you can do to make a company data-driven. So that includes the standardized reports, doing deep analytical insights, and working on data products. So that's the agenda. Finally, I'll give you my thoughts on why all this is not so simple and what makes it so complicated. So let's start with data ingestion. So the task here is to get all the data from the source systems and move it to your data platform. Here, the emergence of all these tools makes it quite simple actually. They're very helpful. So depending on your company's cost sensitivity, you just use a SaaS tool. or an open source tool that will handle most of the issues that you need to deal with when moving data. So as a side note, in a lot of stakeholders, and I bet you've met some people like this, think that this is what data engineers do. So they move data from left to right. It's quite annoying, we know better, all of us here, but it's a common thought out there. So please use ingestion tools and have time for something else. So, I mean, Fivetran and Airbyte, you know, they're your friends, but there's an up-and-coming tool in DLT which is mostly developer-friendly, I would say. The jury is still out, but it's quite good. I'd recommend it to check it out. So there are many complications, of course, when you need to ingest data. So first, you need to deal with a lot of Excel and Google Sheets. So you need to take care of manually input data, probably in the wrong sheet, in the wrong column, and in the wrong format. So that's not so easy. Then, some of the data sources that you need to handle are not supported by these tools. So you need to write scripts, you need to handle API and schema changes, you need to deal with incremental loading and failures. Then, and it's quite often that you can have a back-end team who doesn't really care what's going on beyond that data fence. So they just throw crap over it. And it's our job to catch it, and we need to deal with it. And finally, and this is very, very common, you can have an overzealous data engineer who wants to write all the scripts himself. He thinks that handling API and schema changes is cool. He likes to handle incremental loading and failures, believes that streaming, that's awesome, let's do it. And then also they look at potentially the Fivetran bill that the company has and think, oh, 70K, that's my salary. I can just take care of all of this, and then my salary is paid. And then they spend most of their time moving data from left to right and make that annoying stakeholder right. So let's not make them right. Let's try to rely on the tools that are available to us. Also, and this is quite common as well, we do premature optimization. So there is a time and place for optimizing cost and performance, but often we do this too early. Let's try not to do that as well. So then, regarding the data storage and query engine, so we want a performant, scalable, and affordable database. So the dream. I think it should be clear to everybody here by now that a SQL-based cloud MPP database is the way to go. So SQL is the de facto language for data professionals out there, and it's not going to go away. So if you think otherwise, look up Lindy's law. The MPP here stands for massively parallel processing. So it's a technology that companies have developed for distributed storage and processing of data. So I would say anything you choose from BigQuery, Snowflake, and Databricks is totally fine. There are complications that can happen in choosing the right database, of course. So first, you might be in an organization where they pressure you to use whatever they use as a cloud provider and have all of their infra in it. Then there can be a decision maker who has heard a buzzword like, I don't know, Athena or Fabric, and usually this decision maker is not even technical. So it can be the CFO, so he needs to sign the budget. And you need to deal with that. Also, and it's quite often, you join a company and there is a legacy database there. So you need to have strong convictions to kind of tell the right people otherwise. Finally, There's that overzealous data engineer again. This time he reads Reddit and Hacker News, and he wants to try the latest, shiniest database. Or even worse, he thinks that Spark is the solution to everything. So keep it simple, use a SQL-based cloud database that has been there for a while. It's proven that it works, and try to stay strong in fighting the hype and buzzwords of stakeholders. Then we talk about orchestration, so how you schedule your pipeline and handle all dependencies between the various executions. So here it's quite simple actually. You need to use a scheduler, the simplest one possible, that covers your needs. So anything from, I don't know, like GitHub, GitLab, Jenkins, if you have a use case for it, go something more advanced like a managed Airflow or Dagster. But the point is, use a scheduler, simple one that covers your needs. So this one is tough to complicate actually, but there are some complications that can happen. So you might have a Linux OG who thinks that cron is the way for everything and you can handle everything with cron jobs. Or there's our friend, the overzealous data engineer. This time he wants to deploy Airflow on a Kubernetes cluster himself. Or he finds Dagster's software-defined assets really cool and wants to try them out. They are cool, but you get my point here. So choose the simplest possible scheduler and adapt as your needs become more complicated. Okay, so let's check where we are. We covered those on the left, but now it gets interesting. So we'll talk about data modeling and data activation next. So just to kind of refresh everybody's memory, by data modeling, we mean establishing the single source of truth. So we are here defining and trying to reliably answer the question how many users we have. So this is a trick that I use when I talk to non-data people, and I try to explain the nuances of data and data modeling. So I ask, what's the answer to the question how many users we have? Well, that depends on what do you mean by users, we, and have. So if you think about it, users, all of those three can mean a different thing to all these departments on this picture. So a user for marketing could be somebody who has clicked on a campaign. Then for sales, it's somebody who has bought something once. And for finance, it's somebody who has made a payment in the last 30 days. And then usually they get it, but it's quite tricky. So I'll make a bold, maybe controversial statement here and say that 80% of data teams struggle with data modeling. And I think I'm being nice here. So most of the teams are quite bad at it, actually. So you might think this is survivorship bias. After all, our team gets involved when things are not going so well, and we join to help. But I stand by it, and if you think otherwise, please talk to me later. So what are the simple things in data modeling that I believe every team should do? So first, don't repeat business logic. So try to define what's your user in a single node in the pipeline. Don't distribute this across multiple SQL transformations. There is absolutely no way that you can keep this consistent. And then what happens is you lose that single source of truth, and that's not cool. And you want to be cool. Then organize your pipeline. So there's millions of approaches out there. Maybe not millions, but a few. So you have this bronze, silver, gold. There's staging, data marts, and so on. Our team has a very solid approach where we build layers that build entities, and it works quite well, I would say. So if you are interested more in that, talk to anybody from our team, or team specifically has done some talks in the past about it. Then, for heaven's sake, if you work in data and do data modeling, read Kimball. So the guy wrote a book about data modeling 30 years ago, where he established the foundations of dimensional modeling. The problem is that the book is 600 pages long. This is why nobody's reading it. There's no TikTok version of it. But if you do any data modeling, try to read at least the first few chapters. So it's been in use for a long, long time, and it's proven that it works. Finally, you need to be disciplined. This is absolutely key in data modeling. So there are many, many complications that can happen, of course. First, you need to be disciplined under time pressure, and that's tough. So I know how it is. Sometimes you need to get things done, and you need to get them done now. This is especially true in the age of efficiency. We don't have time to play around so much as up to until 2-3 years ago. Then you might have complicated business processes, and most companies do, which need to be represented in business logic, and this is tough. Also, onboarding people, a lot of people, on data modeling is very difficult. So you need to teach everybody what's data modeling in the first place, and then you need to make sure that everybody will follow the same approach and build something consistent. So that's tough. Then you need to handle with heterogeneous and bad data, and also think about performance and redundancy. So in the age of efficiency, you can't blow up just your virtual warehouse to triple XL and make sure your queries run efficiently. There are many, many more complications in data modeling. But I believe that there's some simple things that can get us a long way. So start with a data model design. So don't just go ahead and start writing pipelines. Think about design. Spend time on design. Then never repeat business logic. Never, ever. If you do, you continue to build up on a messy pipeline, creating a messier pipeline, resulting in a beast of a pipeline that nobody will understand. It requires discipline, but it will take you a long way. Then we come to data activation. So to repeat again, here what I mean is driving the business forward with these three areas. So first, standardized reporting, what was used to call BI. Then having deeper analytical insights where we recognize patterns and trends. And then also data products. So any data product that is built on the data from your data platform, I would put it here, and this can be both internal or external. So think about it like a recommendation system, for example, or a data app that will be used by operations, one of your operations teams. So what are the things that I believe that are simple here? First, ask people what they want. And then build for them easy to consume, very meaningful visualizations. So go talk to people, because they definitely have their Google and Excel sheets, and you want to build automated reports that will keep them away from their Google and Excel sheets. Then have a lot of empathy. So this is crucial in making a company data-driven. So things that are a no-brainer for you are very difficult for people. So talk to them. Try to find where they struggle. They probably rely on copying data from one sheet to another, or 5 or 10, and they rely on 100 of VLOOKUPs. So try to find those things, solve them for them, and then use these people as champions. They will take you in with their open arms. Use them as champions because, I don't know, Thomas from finance trusts Miriam from finance more than trusts you. There are many complications, of course. This is very difficult. I would say data activation is probably the most difficult one because you need to deal with people. So first, people don't want to change. I mean, what has been working for them so far, they usually don't want to change. They often think that their Excel magic beats yours. This is the fact. Everybody has seen this. Then, for your ML projects, let's say that recommendation system, think about, it's probably very difficult for you to get the buy-in from the product engineering team because they need to kind of blow it up, scale it up and put it into production. And usually they don't want to do this, they don't want to put it on their roadmap, so you don't get their buy-in. So this is also a thing to solve. And there are many more. But I believe that there are a few things that are quite simple. So start with the business question. Don't just start with the data. There is this Steve Jobs quote. He says, start with the customer experience, don't start with the tech. It's the same with data. So start by asking people how they use data and what they want. Don't start with what data you have across all systems. Be like Steve Jobs. Maybe not in everything, but in some things, be like him. Then empathy is key. So in making a company data-driven, you need to handle people. Empathy is crucial here. Finally, for your products, try to think simple. Make them tangible. I don't know. Build a demo of your recommendation system in Flask or Streamlit. Something simple that people can see it and make it tangible, and you're also already bringing it closer to production. So think about what you can do. Maybe start it for 1%, launch it for 1% of your customers with pre-computed recommendations in a database. After that, once it takes off, people will be happy to scale it up further. Okay, so to recap, I covered a lot of ground, and these are the simple things that I believe that all teams should do. So first, use ingestion tools for loading data into the data warehouse. Use a SQL Cloud MBV database for your storage and query engine. Use the simplest possible scheduler for orchestration. Then never repeat business logic. Never, ever. And read Kimball. Finally, start with the business questions and ask and give people what they want. So why is it so difficult to do the simple stuff well? Well, smart people are often drawn towards complexity. Intelligent people are pulled towards sophisticated and complex solutions. We think that this is what makes us interesting. So then we talk about it at work, we ask for promotions, we talk about it at conferences. Think about it this way. At a party, the most complex answer will always get the most attention. So if you talk about investments and you say you buy and hold index funds, people will quickly move over to the leveraged crypto arbitrage guy. So this pull towards complexity is a trap, because usually simple things work out better on the long run. As in most things in life, the sum of consistent, regular performances adds up to something extraordinary. It's not easy, but it is simple. Thank you.